All right, so in this recording, in this lesson, we are going to be talking about lesson 1.7, compared decimals. And you can actually find this lesson at page 49 if that helps you get started and finding out where you need to be. But we are going to look at comparing decimals similar to how we compared our whole numbers earlier this year, but this is all about decimals. So let's look at our first example. Luis downloaded 2 songs onto his MP3 player. Which song is longer? So if we're looking at this and we see that song 1 is 3.6 minutes and song 2 is 3.8 minutes. Well, this is a pretty basic one to start out with. And so if we use a number line, 3.6 would be to the left of 3.8. If I were to add other numbers on here and say, well, a number line goes infinitely to the left and to the right. And so to the left, infinitely would go on all the way down to 0 and even into negative numbers. Going to the right here, in this one, it could go on, and so I'm going to put just 4.0 to the right. So if we look at this, to the left is less, to the right is more, is greater. So the numbers to the right are greater than the numbers to the left. So since 3.8 is to the right of 3.6, 3.8, we need to put in our inequality sign, and that inequality sign would be is greater than 3.6. Let's increase our ink size there. Good. All right. So now another way we could do that, because remember, a good mathematician's a lazy mathematician. You're not going to want to draw out a number line for every single problem, right? So another way we can do this, and this is a more efficient way and a much more ensuring that you're going to get it right way, is to line up your decimals, right? So compare the digits in the greatest place. So I line them up, 3.6 and 3.8. It's important to notice that our decimal point is lined up, because that then tells us that our ones place is lined up and then our tenths is lined up. So we can compare the ones digit, 3. They're the same. The ones digit are the same, right? So that doesn't help us answer what we need to put as which one is greater. So we look to the right, continuing comparing until the digits are different. So in the 10th place, 8 is greater than 6. So since 3.8 is greater than 3.6, song 2 is longer. Remember, it's asking you to state which song is longer. Always make sure you're answering what the question is asking you for. So now we can look at another example here. So, decimals that have the same value are called equivalent decimals. So 8 tenths we can write as 0.8. Well, that is equivalent to 80 hundredths, or 0.80. So equivalent is that they are equal. There's a key part of that, E-Q-U-I. That means equal. We'll talk a lot about Greek and Latin roots in math as well, because that will help us break down knowing what words mean. If it's kind of hard to compare the 8 tenths and the 80 hundredths, we could add in lines to, see the difference, or to, see how it would match up. So we'd have lines that go across, and if I match them up ever so carefully here, we can see how we have the same amount of blocks shaded in. I should see I have 10, 20, 30, 40, 50, 60, 70, and then 80 blocks all shaded in if we had it broken out into hundredths. But the problem showed it originally of having just our 8 bars in out of 10 shaded, so that's why it's 8 tenths. So this model can show you that annexing or placing zeros, annex, is a good word that we are going to use a lot in math. Annex means to put a 0 to the right of whatever number you have, right? And that will help us keep our numbers lined up and also easier to compare. So annex means to place zeros. So now we can write our less than, greater than, or equal to in the circle here. So if we're looking at our number sentence of 8.69, 8 and 69 hundredths, how does that compare to 8 and 6 tenths? Well, I think that we could figure this one out of just comparing it, but to ensure that we have it right, let's write out our number and say 8.69, 8 and 69 hundredths compared to 8 and 6 tenths. Well, the directions just said we need to annex a 0. So let's annex that 0. Oh, that's a little intense. Actually, let's just plug it in. Let's bring it down just a notch. So we're going to annex a 0 here. Now I can compare. I can look at my ones place, 8. The 8s are the same, so that doesn't help me answer which one is greater. Now I can look to the tenths place. Well, they're both a 6. That doesn't tell me which one's greater. So now I can look to the hundredths. Let's change that color. And I have hundredth, and I have 9 and 0. They are not the same. So since 9 is greater than 0, I can tell that the entire number, 8 and 69 hundredths, is going to be greater than 8 and 60 hundredths. Because 69 is greater than 60, 8 and 69 hundredths is going to be greater than 8 and 60 hundredths. So 8 and 69 hundredths is going to be greater than 8 and 6 tenths. All right, so let's do another practice here. So we're going to plot each decimal on the number line, and then we're going to identify the which one is greater. So 0.55 tenths compared to 7 tenths. So let's first plot our point. So if I have 5 tenths, I'm going to plot a point. Well, let's not make that blue because it blends in way too easy. So, and actually, let's have a little fun here, right? So I have 5 tenths, and then I have 7 tenths, right? So the problem earlier that we just saw, whichever number is to the right of the other is greater. So if I'm looking at this, the 7 tenths is to the right of 5 tenths. So that means that 7 tenths is going to be greater than 5 tenths. If I'm looking at the next one here, 4 and 40 hundredths compared to 4 and 44 hundredths. So I'm going to plot a point, 4 and 40 hundredths and 4 and 44 hundredths. Well, since 4 and 44 hundredths is to the right of 4 and 40 hundredths, that means that I'm going to put in a less than sign. 4 and 40 hundredths is less than 4 and 44 hundredths. All right, so let's do a little bit more practice here, and then I will have you break to go do some practice work. If you feel like this is, you're solid, you have this taken care of, move on to the practice work. I have that written out there for you to do on Canvas. However, make sure that if you are not sure, if this is still something you want to keep practicing, continue filling out your notes while I'm doing it here as well. So, plot each decimal on the number line and write the inequality sign, less than, greater than, or equal to, in each of the boxes. So 4 and 4 tenths. I'm going to plot a point there, 4 and 4 tenths, and 4 and 1 tenth. Since 4 and 4 tenths is to the right, that means that I'm going to say 4 and 4 tenths is greater than 4 and 1 tenth. 37 hundredths compared to 39 hundredths. Now, I think, and I hope that you can hear that 39 is going to be greater than 37. The same idea, if it was a whole number, it would apply to being a decimal. But we aren't always going to have it be just the same hundredths, the same label, right? So we can plot it, see that 39 is to the right of 37 hundredths. So we would say that 37 hundredths is less than 39 hundredths. And 57 hundredths compared to 65 hundredths. So 57 hundredths and 65 hundredths. 65 hundredths is way down here on our number line. So we would say that 65 hundredths is greater than it. But in the number sentence, 57 hundredths, we have to say, is less than 65 hundredths. Remember, you have to read it still left to right like you read a book. Right, less than, greater than, or equal to make our sentence true. So this one, we aren't making a number line. We're going to line up our decimals. So we need to rewrite this and say 2.15 compared to 2.150. Now, we need to annex a 0, and now I can compare. The 2's are all the same. That doesn't help me answer my which one is greater. The 1's are the same, the 5's are the same, and I even annex a 0, and those are the same. So that should give you a clear indicator that these are equivalent decimals. They are the same. All right, now I'm going to show you another small trick because a good mathematician is a lazy mathematician. I just rewrote both of those numbers. In this, I can rewrite. I'm going to just bring this one over and line up my decimal point and write my 1 there. Because there's no sense in rewriting more than I really need to if I can write this in one spot. And after I do that, I hope that you can see that, one, we have to write our whole number as a 0, but I hope that you can quickly see that since the 1/10 has a digit in the 10th place, it's going to be greater than the 6 thousandths, right? So I can say that 6 thousandths is less than 1/10. Again, I'm going to bring over my other number, 0.647. Now I can compare, and I look at my numbers. 0's are the same, 6's are the same, 5 and 4. So this is where I know that I'm going to say that 5 is greater than 4. So that means that that entire number then, 652 thousandths, is greater than 647 thousandths. Keep on rolling through here. If you are understanding it, go ahead and the video. Go jump into your practice work. If you still need some extra practice here, keep on following along, filling out your notes. I'm here to help you. Make sure that you ask questions if you need help with me during office hours or send me a message. But we have 9 hundredths compared to 1 thousandths. So I'm going to bring over my number, 0.09. Now I can compare. I've got the 0's are the same, 0's are the same in the tenths, and then I've got my hundredths. 9 hundredths is greater than 0 hundredths, so that means that my 9 hundredths is greater than 1 thousandth, right? So we have to make sure that as we say this, we understand that if you have a digit in a tenth, it's going to be greater than a 0 in the hundredths. Just like here, we have 9 hundredths is greater than 1 thousandth. Right? It sounds weird because it sounds like we're saying a whole number, 1,000 compared to 100, but these are decimals. It's that THS is very important. All right, so now I'm going to bring over my other number here, and I've got, let's bring down our ink just a hair. So we've got 7.31, 7 and 31 hundredths compared to 7 and 304 thousandths. So I'm going to compare again. 7's are the same, 3's are the same, 0 and 1. 1 hundredth is greater than 0 hundredths. So that means that 7 and 31 hundredths is greater than 7 and 304 thousandths. And our last one I'm going to do in this is 2.8 compared to 2 and 800 thousandths, right? Because these zeros are going all the way up to the thousandth place, I have to say that whole number, 2 and 800 thousandths compared to 2 and 8 tenths. Well, just looking at it, even if we annex the zeros, they are going to be equivalent. Now, I hope you noticed a small pattern that I did. I was trying to rewrite these problems, right? I brought over the other numbers, but again, a good mathematician is a lazy mathematician. I brought over the number that had less digits to write down, right? Now, some of them were equal. They each had 3 digits I had to write down, but if I can simplify the work that I have to do, why not do that and make sure that I do it correctly and do the best that I can? All right. So if you still have any questions, please send me a message and ask. But otherwise, I hope this helps break down lesson 1.7 on comparing decimals.